Cavium Networks, PureVu Video Modules, Product Training, April 2009. The agenda: we'll briefly talk about Cavium Networks. We'll jump into the module's target market and applications. We'll talk about the architecture the module is based on, PureVu. We will then go into the module overview, and we will finish it with development kits, part numbers, and product availability. Founded in 2001, public in 2007, 350 employees, $75 million in cash, and 10 of the top 10 network and security vendors. 2 acquisitions, ARM and video processors. We are part of the video processor acquisition. Worldwide locations, presence, and a very respected company. Some of the awards that we received last year, very respected young public company. Cavium has 4 processor family: the Octeon, Nitrox, Icona, and PureVu. The module is part of the PureVu. The target markets for the module are latency-based markets: broadcast, it's live communications, interviews, sporting events, security, analytics, determining that there is a threat and without delay responding appropriately, medical, operating room, video is sent to a doctor's office, a pathology or a conference room, real-time, telerobotics, industrial imaging, basically controlling remotely robotic functions, etc. Typical broadcast solution today, which will be a typical broadcast solution of tomorrow. The difference is that we're going to be going from the existing codecs to an H.264 codec, because it's the same quality and half the amount of bits approximately. So absolutely, if they're moving to H.2, they're all going to be moving to H.264. If they've already come up with an H.264 solution, then they're not happy with their latency and they want to talk to us. The block diagram below, basically very simple. You have the HD SDI signal from this professional camera coming in. You have the left and right audio coming in, analog audio. We put those out onto an MPEG-2 DVB stream. They convert that to a microwave radio stream and send that across, and the opposite happens on the truck. A typical example in security, let me just point out, security is a very growth area. Everything was analog and standard definition, is doing a double jump to digital and HD at the same time. H.264 is the chosen codec for this space. Again, same quality, half the amount of bits. You have a central office, you have many remote cameras out there that you're controlling. Analytic-wise, you're reading the data, or mechanically moving the cameras. Typical block diagram, very similar to the last one. The customer will have some type of box they build board that includes our module. All you do is bring the camera input in, audio and video. You have a very simple transport stream that comes out of here that you can then use whatever your communication link is, be it wireless, coaxial, Ethernet. You can also tie in the mechanics here for movement, etc. Here's a telerobotic imaging. You basically have a remote control device, robotic device, that you're controlling and receiving data, imaging from remotely. Obviously you need real-time communication. Again, you see the block diagram is very similar to the other block diagrams. What this is again, most of these are existing systems. The customer already has expertise in doing everything. They just don't know anything about this H.264 codec other than that it does it in half the amount of bits, same quality. We've built all that functionality into this module so the customer can just pretty much put a drop-in replacement into their given system and very quickly develop a solution that has the same quality at half the amount of bits. The last typical example is a medical operating room. Again, here's another place where everything was standard analog video that is now being converted to high definition digital video. So basically, if you look at the right hand picture, you'll see the circular discs. Those are light head cameras in the middle. Basically record the operating room and goes up through this proprietary wiring system into the ceiling to a main station. And then it gets transmitted real time to maybe a doctor's office, to a conference room, to pathology. Everything is converting in this space over to HD. There's a big rush out there right now. The interesting point here is this proprietary wiring. Since they were doing analog SD through this wiring system, you can go to HD digital, and the compression is enough that you can probably use the same wiring system and just put our module in a little system inside that camera head, and no other changes needed. Why PureVu? Basically, MPEG-2, 50% more efficient. As I said, same quality and half the amount of bits. Way more than JPEG 2000, which you will see quite a bit of security. They're having to move over because they just can't handle this high definition. 1080p 30 encode decode. We're within 2% of the joint model, which is sort of the holy grail of what H.264 coding should be. And our testing, again, we're just about as good as the Holy Grail. We can handle bandwidths up to 100 megabits per second. A lot of our other competitors can only do maybe 20, 30 megabits per second. Subframe encode decode latency. We've built into this module bitrate control, error resilient, concealment. All those things are already taken care of for you. Again, you just worry about your transmission and the other parts of your system. A couple slides on latency. Again, no one can come close to what our latency is. Typical industry norm is 500 to 800 milliseconds. We're doing it in a single digit millisecond latency. The Cayman system is somewhere between 1 frame to 2 frames total, end-to-end, camera to display. Here's an example of a real-time solution that we have and the results that we're getting. Okay, here are the specifics and details of our module. The encoder input basically handles 20-bit 422, 601, or 709. This is a standard definition and high definition video format, most typical industrial standard available. We can handle 1080p up to 1080p 30, many other resolutions. We can handle up to 100 megabits per second down to less than 1 megabit per second kind of bit rates. The latency is extremely low from an audio standpoint. We can handle either digital coming in through an I2S bus, or we can handle analog. If it comes in analog, then we pulse code modulate that. If it comes in digital, then we just pass that through. In both cases, we put it onto the transport stream along with the video. The transport stream is an MPEG-2 transport stream. It's an 8-bit parallel, and that's what comes out of this module. Again, very much industry standard. Control, it's a simple serial input control, very easy to control this. It's just some control registers. Mechanical and power, it's 100 millimeters by 55 millimeters by 8 millimeters, very tiny form factor. It's 5-volt input, it's commercial temperature, and I'll talk about the connector in a following slide. Decoder module overview. It is the inverse of what I just described with the encoder module overview. The input to this is the MPEG-2 transport stream, which has the digital audio and digital video. The digital video, it goes through and gets decoded and gets outputted as the 422 YUV standard. The audio comes through and comes out either as an analog line out or a digital I2S PCM.